3-5, Day 1, Rational Functions and Their Graphs. Our learning goal is that you will be able to find the domain of each rational expression and use arrow notation with rational expressions. So example 1, we're going back to domain. Now in the previous section we were doing the restrictions. Domain is a little bit different because we're going to use interval notation. So what you're trying to do is find the values of x that you can use without making the denominator 0. So usually domain would be all real numbers like this, unless there is an x in the denominator or a value of x that makes the denominator 0. So a value of x that makes denominator 0. So look at example 1a. Is there an x that would make the denominator 0? So if you said 8, you were right. So that means we can use everything except for 8. So everything to the left would be negative infinity to 8, not including, union 8 to infinity. So you've done this before. This is like review. B, is there a value of x that would make your denominator 0? Actually, there are two of them. 2 and negative 6. And when you do your domain, when there are two of them, you have to make sure you do smallest to largest. So negative infinity to negative 6, not including, union negative 6 to 2, not including, union 2 to infinity. C. Now C needs to be factored first. X plus 8, x minus 8. And then you do. Is there a value of x that will make your denominator 0? There are two of them. And remember, we have to do it smallest to largest. Negative infinity to negative 8, union negative 8 to 8, not including those two, union 8 to infinity. And then last, D. Now, D can't be factored. You can set it equal to 0. And what you're going to notice is x squared equals negative 64. If you try to square root it, you're going to get a non-real number. What that means is there is no value of x that will make your denominator 0, which means every value of x is safe. So you can use all real numbers, which will be the entire number line. Example 2, we're going to use what is called arrow notation. We're going to use the graph. They have graphed a rational function, so when we get ready to graph rational functions, that's how they're going to look. If you notice on this graph, we have two vertical asymptotes. That means your graph is getting really close to the line, but it won't touch it. And then we have a horizontal asymptote. Now your graph usually crosses the horizontal, but it can't cross the vertical. It usually crosses the horizontal in between the two. So when you see this symbol, this means approaches or gets close to. And you'll see the number. So for example, you see negative 3. If you see this symbol right here, that means we're approaching from the right. If you see a minus, that means we're approaching from the left. All right, so let me show you how to read example A. As x approaches negative 3 from the right, so here's negative 3. If we're approaching it from the right side, f of x, that means your y values are going up to positive infinity. Okay? B, as x approaches 1 from the right. Let me erase this so you can see. So from the right side, that's this side, f of x, or your y values, are going up to positive infinity. C, as x approaches positive infinity, so here's positive infinity going this way, f of x approaches or is getting close to, if you notice, is not passing this line, and this line is where y equals 0, so it's right here. So we are getting close to 0. So when you're going out to infinity or negative infinity, you're going to get close to your horizontal asymptote. So that's only for positive and negative or negative infinity. Example 3 is the same directions, but we have a different graph. So remember, when you see this symbol, this means approaches. So for A, it says, as x approaches 1 from the left. Here's the vertical asymptote 1. Notice in this picture I have 2 vertical asymptotes and 1 horizontal. So I'm looking at 1 and I'm coming from the left. So if I come from the left, my y values are going to negative infinity this time. B, as x approaches negative 2 from the left. So here's negative 2. And on the left side, notice my y values are going up. They're increasing. So now we say it's going to positive infinity. And then last, we have as x approaches negative infinity. I'm going to use a yellow. So I'm going towards negative infinity. And notice my y values are getting close to this line right here, which is our horizontal asymptote. And it says here that that is 1. So they are getting close to 1. So remember, when you're going out to negative and positive infinity, you're getting close to your horizontal asymptote.